Hi, team. Welcome to a terrific Math Thursday. And we're continuing our EQAO practice. It's one of my favorite sections, even though it makes up a smaller part of our course together. These questions have a real puzzle like quality to them. For all of these questions, here's what's absolutely essential. It's essential that you struggle with the question first before watching my solution because you want to build your own thinking. You don't need to get the right answers on the practice booklet. You need to develop your thinking with the practice booklet. So you're going to do that by doing your thinking and failing, or doing the thinking and succeeding. Okay? Failure or success is less important on the practice booklet than the thinking. Okay? So if you struggle and then watch this video and then learn something from my thinking, then that thinking can take root and help you solve future problems. If you don't make the effort first, this is not the way to use this video. Now, let's, with that caveat, with that idea in mind, let's go ahead and I'll explain my thinking on all these problems and show you roads to solutions and how you can approach them. There's 29 questions, no way to divide that up into smaller chunks except for 29 videos of one or one video of 29. So we're going to try and do this in, we'll do it in 3 goes. We'll do it in 10, 10, and 9. All right, let's go. So here we go. This is an isosceles triangle, and we want to find this value of m. All right, this value up here of m. And one thing that's important to note about an isosceles triangle, if you have two sides that are the same length, these angles are the same. The angles of a triangle always add up to 180. So 180 will be 2 times 70 plus m. See, there's two 70-degree angles and one m. So we want to solve this. And then we find that m is 40. 180 equals 140 plus m. And I need to add 40 to 140 to get 180. So it's 40 degrees. Examine this figure, okay? This is a tricky question. The reason it's tricky is because all of this part of the diagram is not important. We're given, again, an isosceles triangle, and we're asked to find the measure of FEG. The way we read these angles is you start from the first letter and read to the next letter. Usually the angle is at the middle letter. So it's this angle here we want to find. So if we have a 72-degree angle, okay, up here, and then these are the same, then I know these are both the same angle, okay? So, and that's 72. Let me just work on the existing diagram rather than that junky thing that I just drew. Okay, so let's go. Here we go. This angle at FEG is going to be the same as FGE because it's an isosceles triangle, so we'll have those two angles the same. So then I get this equation, 2 times the angle x plus 72 equals 180. And now to solve this, I subtract 72 from both sides. And that gives me 2x is equal to 108. X is equal to 54. How did I do that? Well, I divided both sides by 2. There it is. Okay, let's keep going. All right, and in this figure, BC is extended to D. Okay, angle BAC is 42 degrees as labeled, and angle ACD is 105. What's the measure of angle ABC? What's the measure of angle B? Okay, so here we're going to use this fact that at that angle ACD, this is actually, there's a straight line here, and that straight line will add up to 180. So this angle in here is 180 minus 105 equals this angle right here. So that's 75. Okay, so this angle here is 75 degrees. That's because this plus this has to add to 180. So now we've solved this angle here, and now we can solve this angle using the three angles of a triangle add up to 180 property. So then we have 42 plus 75 plus angle B here, okay, plus B equals 180. All right. And then I do this math. So 42 plus 75 happens to be 117. 117 plus b equals 180. And then now I subtract 117 from both sides to give me 63. 63 degrees is this angle. Okay, let's keep going. Consider this diagram. So now they're giving us more puzzle-like things. We want to find this angle here, x. And to do that, we really need to work with this big triangle. And one thing we know is that this angle is 90 degrees based on that square mark. But we don't know this angle up here. But we're told that there's an isosceles triangle up there. That means this angle is 76. And this angle, don't know what it is, call it y. All right? Y plus 2 times 76 equals 180, because that's a little triangle up there. Its angles will add to 180 like any triangle. 2 times 76 happens to be 152. So I have y plus 152 equals 180. What do I need to add to 152 to get 180? Well, it's 28. Y is equal to 28. If you're not sure, subtract 152 from both sides. So that's not the answer. It's part of the answer, okay? Now, I want to find x, okay? So if I know that y is 28 degrees, then 90 degrees, this one, plus 28 degrees, that one, plus x is equal to 180. 90 plus 28 plus x equals 180. 90 plus 28 is 118. 118 plus x equals 180. And now if I subtract 118 from both sides, I get x is equal to 62. There, this is the answer that we want. Okay, so that's how you would solve this question. The main process is work from what you know towards what you don't. Okay, I don't know x, I also don't know y, and I recognize that I'm going to need y to find x. I can find y through these numbers and the isosceles triangle property and just work it step by step. Work from what you know towards what you don't. Okay, a flower pot is hanging from a brace. All right, M and Q and M and P form the brace. Okay, these two triangles. Okay, what is the measure of x? Okay, so here again, I need to work with what I know towards what I don't. All right, so if I can find this angle y, then I know that x plus y equals 90. So I need this angle y, then I can find x. Okay, so y plus 110 plus 30 equals 180. So y equals 40. Check it yourself. Okay, if you can do these fast in your head, then do that. X plus y equals 90. So x equals 50. All right. Am I going too fast? Yeah, probably. So 110 plus 30 is 140. 140 plus here 40 degrees for y gives me 180 in this triangle. I also am told that this makes a right angle and that y plus x is that right angle. So 40 plus 50 would be 90 degrees. So x is 50 degrees. Okay, let's keep going. Pardon me. ABC is an equilateral triangle. Well, that's cool. Equilateral triangles have a cool property. All their angles are the same. Let's see what we need. So I need the angle ADC. Wow. All right. Okay, let's do it. So what is the measure of ADC? Well, I need to first find this angle C, okay, to find that. Because then I can do this plus that equals 180, and I'll be able to find it. But I can't just find C right away. Well, actually, I know what C is. I can look at it and tell you. The reason I can tell you is because this angle is the same as that angle, is the same as that angle, because they're all equilateral triangles. So that's an equilateral triangle. So 3x equals 180. Okay, 3 times that angle is 180. And then you divide by 3 and you get x is equal to 60. Okay, so this has to be 60 degrees. And then we know that this angle here would be 180. So this has to be the difference between 180 and 60. So that's 120. All right, so let's put that on there. Notice I'm just working from what I know towards what I don't know. 120. Okay. Now 25 plus 120 plus this angle will be 180. So you can write that out if you want, and you'll have 120 plus 25 is 145 plus angle D equals 180. And then you can solve this equation to find that D is, what is that, 35? Yes, 35 equals D, because that would add to 145. 180 minus 145 is 35. There we go. Consider this diagram. Which of the following equations is always true? X equals A plus B plus C. This one is fun. Okay, this one is very much a puzzle. Okay, let's try it. Which of these is always true? So here's what we can do. Create equations and play. All right. C plus X equals 180. Okay, what else equals 180? A plus B plus C equals 180 because they all occur in a triangle. So C plus X equals A plus B plus C because they both equal 180. So so this side must equal this as well. And now I can subtract C from both sides to get X is equal to A plus B. Is that one of the options? Yes, it is right there. There, cool. All right, that's all you do. Play with the algebra. See what it shows you. And then later you can use that algebra to show you, oh, wow, okay, so A and B, these angles, they must fit in there. Like that would be angle A and that would be angle B. And that's like this cool thing that I can remember about straight lines coming off of the edge of triangles because the algebra shows it's true. Okay, ABC is a triangle. AB is extended to D. Very good. Good for you, AB. You extended to D. And then what type of angle is angle CBD? Well, let's find out. Okay, there's four kinds of angles. Straight angles are 180 degrees. Obtuse angles are between 180 and 90. So they're bigger than 190, but they're less than 180. Acute angles are less than 90 degrees, and reflex angles are more than 180, like this. Okay, you won't find reflex angles inside triangles. Now, let's go. So, and because this is practice, you can look up definitions like this online. Now, let's find this angle in here. 40 plus 45 is 85. So 180 minus 85 gives us 95 degrees here. This would be 180 degrees. So this would be 85 degrees. 85 degrees is less than 90, so this is an acute angle. It looks acute on the diagram as well. If you just look at it and you're like, oh, that's an acute angle, then you know. Okay. Now remember, with these 12-sided shapes, or however many sided shapes, let's say like a triangle is 3 sides, and it's one triangle. Okay, so it's 1 times 180. A square, or any 4-sided shape, can be divided into its 4 sides, and it's 2 triangles. So its interior angles sum to 2 times 180, or 360. With 12-sided shapes, again, the pattern is true. It's 2 triangles less than the number of sides. So it's 12 sides. That means it's 10 times 180, and that's equal to this number. Just add a 0 to 180. Okay, so that's the sum of the interior angles of a 12-sided shape. What if it was 20-sided, Mr. Jennings? Well, a 20-sided shape could be divided into 18 triangles, always 2 less. So I would do 18 times 180, and that would equal some other number. I can't remember the square of 18 right now, and as you can tell, I'm not really in the mood for mental math. So we're going to move on. Aha! ABCD is a quadrilateral. So here we go. It's a 4-sided shape. That tells me its interior angles all add up to 180, and and the angles are all versions are all different amounts of x. So there's a common factor here. So here's what I can do. I can add up all the angles. So I can say x plus 4x plus 3x plus 2x equals 360. And from this, I can solve for x. First, collect all your like terms. 5x plus 5x, this is 10x, equals 360. So x equals 36. And we want to know angle BAD. So what is BAD? Well, it's going to be 4 times 36. 4 times 36 happens to be my favorite number, 144. Okay, that's the end of this video. So I'm going to make 3 videos for you with all these questions. So if you have any questions about any of the things that you're seeing here, this is really like a lot of your algebra is showing up here, and your problem solving and thinking skills are going to be tested. So if you're wondering how to approach these types of problems and you have questions about that, absolutely ask me in class or hit me up by email. The secret code word for this video is foam dice. Bye for now, everyone. Oh, where's my off button? Oh, you get this awkward time before I push the off button.